Hello and welcome to this Simply Rhino video created for you by our team. We trust you'll find the video useful and that you enjoy the content we've created for the Rhino and Grasshopper community. If you'd like to know more about the Simply Rhino team, the Rhino and Grasshopper training we offer and the events we organise, we'd invite you to visit the Simply Rhino website. Now, please go on and enjoy the video.
Hi, this is Phil at Simply Rhino. In this video I'm going to look at creating deep buttoned upholstery and creased or pleated features using this example of a 1970s chair that I saw in a gallery in London. What drew me to this chair, by Adriano Piazzezzi, is not only that I'm a big fan of 1970s furniture, but also that the tubular metal frame has a structural resemblance to a chair that I designed and prototyped about 15 years ago. I've been asked many times during our Simply Rhino training sessions about creating deep buttoned upholstery, and now that Rhino has a full set of SubD tools, this workflow has become somewhat easier to explain. I've made a number of versions of the upholstered parts of this chair, and these images show a rendered example of perhaps one of the more successful examples. Of course, it's not always the case that such detail has to be modelled as geometry, but if the aim is to explain upholstery details to manufacturers, or to create close-up shots from various angles for marketing purposes, then it becomes worthwhile. The following workflow doesn't always show a step-by-step process and assumes some existing knowledge of Rhino and SubD geometry. However, if you're looking at some possible techniques to employ, then I'd hope it will be useful. The starting point is some very simple NURBS geometry. Leaving aside the two cushions until later, there are three separate elements: the seat sling, the tubular frame, and the bolster. The bolster is represented here by a simple solid created from a piped curve, and the set-out geometry for this was these curves. I created a C-plane aligned to the centre of the bolster, and, looking at this in plan view, we can see that it is almost symmetrical in X and Y. This part here is slightly longer than the other linear element, but in order to create the simplest starting SubD geometry, I'll make the corner piece symmetrical and then stretch or scale this part later. With this in mind, I can work on just this area, which represents 1/16 of the overall shape. It's important that the topology of the SubD is controlled and consists of a four-sided structure to begin with. And to ensure this, I'll create a SubD that is based on a series of curves like this. To create these curves, I can use curve, point object, divide curve by number of segments. And I'll divide the lower edge here by 4 segments and this edge by 8 segments. Next, I'll go to curve, curve from objects, extract isocurves, and then pull out the curves, snapping to the points I've created. Then I'll duplicate the edges and repeat the process on the other parts of the polysurface, leaving a network of curves like this. Next, I'll split these curves with each other by first selecting all of the curves and running curve, curve from objects, intersection. This will create a point where the curves touch each other, and I can then use these points to split the curves with. Finally, I'll select all the curves and rebuild these as lines by setting a degree of 1 and a point count of 2. Next, I'll create a mesh with this exact four-sided topology by using mesh from lines and making sure that the max side per face setting is set to 4. Then, from the SubD toolbar, I can convert this mesh to a SubD, making sure the control option is selected along with mesh corners. This will build a SubD that, when displayed in boxy mode, will look exactly like the mesh. Now I can start working directly with the SubD. Having built a few of these bolsters while researching the method for this video, my strategy is to first build the overall or general creases and then put in the more defined corner creases or pleats afterwards. The first step is to add some edges by using the Insert Edge command with the range option on, and I'll do this on a portion of the straight section here to show the process. Once the edges have been added, I'll remove alternate edges at each side of the bolster shape, and the resulting 5-sided surface will help the crease to wash out gradually. To add the crease, I'll use the 4 middle edges, and to select a region like this, I should be able to pick the first and the last edge of the region and then double-click on one of the edges in between. Using the gumball with the Align to Object and Smooth Dragging options selected, I can gently move the selected edges inwards to create the soft crease or undulation. I'll repeat this process on the remaining edges in the region, and to stop the result from looking too uniform, I can select some edges and move them sideways to get a result that looks more arbitrary. To help show the effect of this sculpting, I could of course use the environment map, but it may also be helpful to create a simple leather texture material. I can then map this to size with a simple box map and check the result in rendered mode. Now I've gone a little further and added in more detail using the same iterative process. When we look at this in rendered mode, it looks like this could be a little too exaggerated. And before adding in the corner creases, I could try a process to make this a little more subtle. And I've found that quad remesh can help here. Using a target quad count of 800 with these settings, basically converting to a SubD using interpolation, the result looks pretty good. And it basically softens everything while keeping the overall appearance and, of course, the rectangular topology. Now I'll take a look at adding the larger creases or folds. There's 4 at each corner, so there'll be 2 in this section. Where the creases are located, I'll insert an edge with the both sides option on. It's easier to do this in the boxy mode as the edges can be placed closer together. I can then pick a range of edges and pull this edge outwards with the gumball. Because the edges are close together, the resulting crease will be well defined or sharp, and I can then accentuate this further by taking the adjacent edge and pulling these inwards in a normal direction and sideways towards the higher edge. The intention here is to create more of a pleat or fold, and initially this looks too sharp. So I'll pull the edges further away from each other in an attempt to soften the result. There may be quite a lot of iteration here until I'm happy with the result. Once the first pleat is done, I can repeat the process on the other crease and again move some arbitrary edges sideways to reduce the uniformity. Before mirroring and copying the result, I'll make sure that the edge vertices are aligned. So, starting with this left-hand edge and working still with the custom C-plane aligned to the centre of the bolster, I'll set a plan view. I can then pick points on the edge and use Set Points, set XYZ coordinates from the Transform menu, with the Align to C-plane option selected, and align them to 0 on the X-axis. I can then use a similar process on the other edges of the SubD. Moving back to the plan view on the bolster, I can now mirror the corner. Initially, this will create a sharp or creased transition, but I can then join the 2 SubD parts together using the Smooth option for SubD joined edges. Switching to the perspective viewport and using the rendered display mode shows that the resulting join is now smooth and the overall result looks good. Because the bolster isn't symmetrical and yet I've modelled it so, I now need to lengthen the one edge to match the NURB solid that I'm using as a template. The most sympathetic way of doing this is to scale a number of faces rather than merely lengthening the edge. I'll go back to the plan view on the bolster and turn the project constraint on. Then I can enable the face filter and select the relevant faces that I'd like to scale. Then I can use Scale 1D from the Transform menu to stretch out these faces, snapping the edge to 0 on the Y-axis. Using the direction lock or tab key constraint here will help to constrain the direction of the scaling. I'll check that the result looks okay with both the environment map and then the rendered mode, and then gradually mirror and join the elements together, checking for smoothness and consistency as I go. Once joined, the result looks pretty good. I could do some local editing to reduce any obvious signs of symmetry and mirroring in the creases, but for now I'll leave this as is. All that needs to be done now to finish the bolster is to add the cylindrical seams at the top and bottom and the piping around the outer perimeter. To add the seam, I'll switch to the boxy display mode and then pick the center edge here and then insert an edge both sides of this, keeping the new inserted edges close to the original. With the original edge still selected, I'll turn the gumball on, switch to the right ortho viewport, set the gumball alignment to C-plane and scale the center of the seam inwards. Then I can check the results in rendered mode and adjust if necessary. I'll then use the same process for the lower seam. For the piping, I'll go to Curve, Curve from Objects, Duplicate Edge, and then double-click on this center edge here to extract a closed polyline. Then I can use SubD multipipe to create a pipe with a radius of, say, 3 mm, and this creates the piping. Looking at the frame, seat and completed SubD bolster, we can see that the chair is now starting to take shape. The workflow for the deep buttoned upholstered cushions is slightly different, but still involves the use of symmetrical SubD parts that can be edited afterwards to reduce the obvious symmetrical aspects. The back and seat cushions are essentially the same, so I'll just look at making the back cushion here. The starting reference is just a solid box modelled in NURBS, and once again I'm going to use a Mesh from Lines workflow. The layout here describes half of the cushion, and the line boundaries here will create 3 and 4-sided faces. The obvious aim here is to create a layout that will quickly create the basics of the deep creases created by the buttoning. With the mesh having been created, I can then convert it to SubD, making sure to use the control option in the mesh settings as previous. When we view the SubD in boxy mode, then it looks exactly like the lines and mesh it was built from. Next, I'm going to extrude the SubD edge to create a depth that is roughly half that of the desired cushion thickness, and then I'll add 2 edges into the side surface with Insert Edge. For the next part of the editing, I'm going to work in smooth mode, and the first thing I need to do is to push out this edge to give the cushion some curvature, which will give it the appearance of it being filled. I'll make sure that smooth dragging is set in the gumball options and pull this edge outwards to create the plumped up effect. I could then push the central faces that sit behind the button back slightly to further accentuate the button recess. To select these faces, I can go to a plan view and then choose brush selection and pick the face sub-object selection here. And if I have the crossing selection mode set in cell brush options, I can just brush around the center here and this will select the required central faces. Then I can go back to the perspective viewport and push those selected edges inwards slightly. Now I can start to make the creases or pleats that are created by the button pulling the upholstery inwards. I'll look at just one crease to start off with And first of all, I'll clear the face selection here and then pick these two edges before moving them in slightly. I could then choose to either carry the crease over the edge or wash it out smoothly before the edge. I could also sharpen the recess by adding a soft crease. So, if I pick these two edges here and then add a 60% or even 80% crease, this will add more definition without changing the topology. Although I haven't added the other creases as yet, the topology that I created at the start is already starting to describe the crease layout I'll need. So now I've pulled in the other edges and created all the main creases and attempted to make them less uniform. To sharpen up some of the creases, I can use Insert Edge and then push the adjacent edge inwards to create the folded over pleat. To wash this crease away a little more, I can pull this edge outwards. Because this edge is now sharper, it's easier to make this look less uniform. So, if I now pick these edges here and move them over to the right, then when I check this in rendered view, this is going to look much better. So now I've repeated the process on the other creases, and this is now starting to look a little better. In order to help visualize the intended result, I've added the button, which is just a SubD ellipsoidal shape. When putting in the creases or unevenness around the edge of the cushion, I think it's important that these have some relationship to the deep button creases. So, if I look at this edge here, I can insert an edge which will restrict the length of the crease like so. Then I can pick these four edges and insert edge again using the both sides option. It might help to do this in boxy mode, and then I'll pull these three edges inwards, making sure the gumball alignment is set to C-plane. Then I'll switch the gumball alignment to object and pull this edge inwards. Next, I'll add a soft crease here with just a 20% amount at this point, and then I can pull this edge in again by just a small amount to accentuate the crease before checking the result in rendered mode. Using the same principles as previous, I've now added more detail around the outer three edges of the cushion. The fourth inside edge doesn't have much going on because this is going to be removed prior to mirroring. Some of the corner details look a bit sharp at the moment, but these can be softened once the cushion has been assembled. I'll remove the faces on the inside edge of the cushion, and then, using a process similar to that which I used with the bolster, I'll set the points on the inside edge of the cushion and then along the rear edge. This will ensure that the four elements will join together properly. I'll switch back to the perspective view and make sure the C-plane is set to the custom back cushion. And then I can pick the cushion and the button and mirror these about the C-plane Y-axis before joining the two halves of the cushion together, making sure to select the smooth SubD join option. Looking in rendered mode, the result is okay, although obviously very symmetrical at the center. But something else that is wrong with this is that the buttons are too far away from each other. Because SubDs are very robust, it's really easy to move the deep button creases inwards whilst retaining the shape and structure of the cushion. Looking at an example of a cushion I made earlier reveals where the buttons should be located. So I'll create a line to reference the approximate center of the left button, and then, working on half of the cushion at a time, I'll turn on the vertices and select an area that I'd like to move inwards. I'll include the button in this selection. And then, with the project constraint on, I can move the selection inwards, aligning the button with the reference line. I'll then repeat the process on the other side of the cushion and check this in rendered mode. Moving the deep button feature has worked well, but the center remains very obviously symmetrical. So next, I'll look at fixing this by doing some local edits. Not only push-pulling and moving faces, but also removing some edges to change the topology locally. Here's the result after some editing. I could go further, but this probably gives enough of an idea of the process to progress to the next step. I'll mirror the result to create the back of the cushion, and starting with the custom C-plane active, I'll move the C-plane to the back face of the SubD and then set the view to plan. Next, I'll set the camera to C-plane left, set the C-plane to view, and then double check that we're still in parallel projection. Then I can turn on the vertices and set the points to the C-plane X0 position, just in case I inadvertently moved any edge points whilst editing. Then I'll mirror about the X-axis before joining the result. I'll check this in perspective view and then look at softening the edges of the cushion by removing some edges and doing a bit more local editing to reduce any obvious signs of symmetry. Finally, I'll group the buttons and the cushion together, copy the group to create the second seat cushion, and then gradually move these into place. Looking at the result in ray trace mode, it looks okay with just a simple textured material. But of course, this could be made to be much more realistic with a more complex material. In any case, I hope this gives you some ideas and possible methods to create creases, pocketing, and undulating features in upholstery. That's about all I wanted to cover in this video. Thanks for watching, and please feel free to leave any comments below. If you found this video useful, then please hit the like button, and remember that to keep up with the latest developments in Rhino, you can subscribe to this channel. At Simply Rhino, we offer training for Rhino and all its key plugins, so check out our website for more details. Thanks again for watching, and I'll catch up with you in the next video.